Welcome to section 3.2, Solving Systems. Algebraic now. Yay.
Today we're going to solve systems using the substitution method. So we have two methods. We're going to do substitution first, then we're going to look at elimination. So other than graphing, what we can do is, in order to substitute, we have to have one of the variables solve for itself. For instance, in the first equation, notice we have x equals. In the second equation, notice we have y equals 3/4 x. And in the last one, 3, we don't have any. So we're going to have to get one there. So in the first one, if we take this 2y and we substitute it in for x there, we're going to get, with parentheses, we're going to get 2 times 2y minus y equals 6. Distribute or multiply, so we get 4y minus y equals 6. So you get 3y equals 6. Divide by 3, you get y equals 2. Okay, from there, what we want to do is we want to take that last problem, and we can take it and we can plug it all the way back into that first equation again. So we get x equals 2 times 2, so x equals 4. So the system answer that we have is 4, 2. If we go back to, again, the last section, how do we call that? Well, it is a point of intersection, so we can say it's consistent and it's independent. Number 2. Notice we have the second equation underneath is already solved for y. So what we can do is we can take this 3/4 x, plug it in for the y in the above, and rewrite. So 6 times x minus 8 times now 3/4 x plus 3 equals negative 24. Distribute the negative 8 through. We'll get 6x. Negative 8 times 3 is negative 24. Divided by 4 is negative 6x. And then when we multiply the negative 8 through, we get negative 24 equals negative 24. Notice this x's cancel, so our variable goes away. Ding, 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 ding. Little light bulb should go on and saying, okay, we have one and two way methods, especially from graphing. We have no solution, or we have same line, many solutions. Well, if we notice, we have negative 24 equals negative 24. That is a true statement. So this is a many solutions. Classification, we would say consistent and dependent. Hit pause, do number 3. Welcome back. If you look at number 3, notice I took the first top equation, solved it for y, got y equals 2x minus 5. Then we substituted into the bottom equation by multiplying. You notice, yes, again, we get another variable that goes away, so we're left with just two numbers. So this is either, again, parallel lines, no solution, or same line, many solutions. Does 10 ever equal 4? No, it's a false statement. Therefore, it is a no solution, inconsistent. If we take a step further and say, well, what if we throw one more equation in here? So now we have 3. It's okay, not that difficult. We just take it step by step. So notice, if I glance over all 3 of them, notice the last question. So if this is A, B, and C, if we look at the C, there's only one variable. So let's go ahead and we can divide by 6, and you already have one answer. It's negative 4. So Z equals negative 4. Okay. Now by substitution, what we can do is we can take all of these, and we're going to go and plug in negative 4 there, and we're going to plug in negative 4 here. So I need to rewrite the A equation. So we'll get x minus y minus a negative 4 equals negative 4. We get x minus y plus 4 equals negative 4. X minus y equals, if we subtract that over, you get negative 8. So there's one equation. If we look at the bottom one, or the middle one, right here in the B question, that needs to be equal to 7. I apologize. So that's 7. So now when we do the B equation, or even the first A equation, if we take the middle one, 5x plus 2y minus 3, and this is plug in negative 4 equals 7. When we get in here, we get 5x plus 2y minus 12. No, plus 12 equals 7. When we subtract the 12, you get 5x plus 2y equals negative 5. So there's our two equations. Now what we want to do is we want to solve for one of the variables. Since the red ones have a 5 and a 2 as coefficients, and the other one in the green only has a coefficient of 1 and negative 1, let's solve for x by moving the negative y over, and we'll get y minus 8. Now what we want to do is we want to take this y minus 8 and substitute it in over here. So we're going to get 5 times y minus 8 plus 2y equals negative 5. Distribute through and you get 5y minus 40 plus 2y equals negative 5. If we move the 40 over and add this, we get 7y equals 35. Divide by 7, y equals 5. So now we have two parts. We already have the z equals negative 4. We already have the y. Now we're going to take this one and we're going to substitute it, and we can pick one of the equations. So let's just pick, so let's say, okay, if we need x now, x, we have y. Y is 5. And then we have z is negative 4. Okay, that should be equal to negative 4. So x minus 5 plus 4 equals negative 4. X minus 1 equals negative 4. Therefore, x equals negative 3. So the answers are negative 3, 5, and negative 4. Considering we have three variables, here's how we write it in the coordinate system. We'll say negative 3, comma 5, comma negative 4. And the last part is to solve the equations by elimination, which means we need to make sure that x and y are both on the same side. So in the first equation, notice x and y are lined up and on the same side. Number 2, we don't have both x and y on the top one on the same side, so we're going to have to move the x over, but the bottom one's okay. And also on both for 3, we're going to have to do some manipulation there. So number 1. Since they are both on the same side, I have to look at the x coefficients, the 3 and the 2, or the negative 2 and 1 on the y, and figure out what's easier to eliminate. So for instance, if I take the bottom equation and I multiply by positive 2, since the y on the top is already negative 2, if I multiply this bottom by 2, you're going to get 4x plus 2y equals 26. If I take and bring this down and say 3x minus 2y equals 2, notice what we have is these right here, these are opposites, and that's what we want. We want to get opposites so that we can add them together and get 0. So when we add straight down, we're going to get 7x, this is 0y, equals 28. Now we have one variable. You can divide by 7, x equals 4. Now it becomes the last problems that we did. Use substitution. Take this 4, that's an x, plug it into one of the equations, and then solve for the other variable. So 3 times 4 minus 2 times y equals 2. Negative 2y. If we subtract the 12 over, you get negative 2y equals negative 10. Divide by negative 2, y equals 5. So our point is 4, 5. This is a solution, so therefore we are consistent and independent because it's one point. All right, number 2. Manipulate. So what we need to do is let's move this x over here. We're going to get 3x plus 5y equals 4. And we already have 5x plus 7y equals 6. So what you want to figure out is, well, what is easier to get rid of? Is the x's get rid of or the y's? Well, notice 3 and 5 don't go in each other, but I know that 15 is a multiple of those, and the same thing with 5 and 7 or 35. Your choice. Would you rather work with a smaller number in 15 or a larger number in 35? Me personally, I would choose the smaller. So let's get the x's away by making them, one it has to be 15x and the other one needs to be negative 15x. Well, in order to do that, we have to multiply a 5 to the top and we have to multiply a negative 3 to the bottom. So when we get that, we get 25y equals 20. And on the bottom you get minus 21y equals negative 18. Now we can get rid of those x's. 25 minus 21 is 4y. 20 minus 18 is positive 2. Divide by 4 and you get 1/2. Okay. What we can do now is we can go back to the original equation, plug in 1/2 for y. I know it's a fraction. It's okay if we do that. So I'm going to take this. I'm going to plug it in for that y there. So we'll get 5/2 by multiplying equals 4 minus 3x. If we subtract the 4, you get minus 4 plus 2.5 equals negative 3x. So therefore, if we put this side together, common denominator, you can get plus 5 is negative 3 over 2. So we get negative 3 over 2 equals negative 3x. If we divide by negative 3, you also get x equals 1/2. So our point is 1/2, 1/2. This is, yes, consistent and independent. Go ahead, hit pause. Do number 3. We'll check back with you in one quick second. Alright, welcome back. So notice what I did is I put x and y on both sides, and then I thought, well, between 4 and 6, which both go into 12, and I saw 6 and 9, which both go into 18. I chose 12, so I used 12 and negative 12 to get rid of the variables here. So by doing that, you end up actually both variables cancel. So when both variables cancel, we have to think about parallel lines versus the same line. Does 0 ever equal 10? No, 0 does not equal 10. So it's a false statement. Therefore, the answer was no solution. Parallel lines. It is inconsistent. Congratulations. That concludes. Make sure you remember.
Do your best, forget the rest. Bye for now.